Okay, hi everyone. So what we're going to do now is just recreate some parts of the final OSC operation with the IMU to graphical outputs here. I'm going to create some of them from scratch with you, just so you can learn how they work by creating them yourselves. So I've got a new TouchDesigner file here. If you've got some default operators here, you can just right click, select them all and hit delete. Mine starts up completely fresh, yours might not. But what we want is just a nice fresh canvas like this. Okay, so first of all, let's grab our OSC input. So I'm going to double click with my left mouse, go to chop and go to OSC in and just lay that down here. I'll zoom in. I'm going to set that network port to whatever it has in my bridge, which at the moment is 8888. So let's go 8888. And we're getting nothing. Why is that? Oh, it's because I've got my other TouchDesigner running, of course. Okay, that would explain a lot. All right, so let me just turn that off. See if that's enough to grab our signal. No, I might actually have to. I'll just change that. Yeah, because you can't have two sensors looking for the same signal. So I'll just put that to 0, 0, 0, 0. Okay, so there we go. Okay, so now that's a bit happier. We're getting our signal. Okay, so as we'll discuss in throughout this week, you know, the wonderful thing about an IMU is all of these different raw values we get, as well as how we can process these values. So you can kind of see by looking at them, our first value, the way we wrote the bridging app, is simply time, right? That's just giving us integers counting up as we're using the device. So then raw 2, 3, 4, our accelerometer values, and that as raw values are quite convenient to use for rotation. I think we'll have some theory sort of explaining what these are. But basically, if you hold your SensorTile on the table flat and rotate it on one axis, you can usually get a pretty clear reading of which axis is correlating to which raw value. When you're holding it in the air, it's a little trickier to see because usually we're moving more than one axis at once. But here we can definitely see when I'm rotating the tile sort of parallel to the USB power, I'm working on raw 3. So that's what I'm going to use in this tutorial. So in order to do that, first of all, I'm going to, there's a few ways I can do it. I can just double click again and I can grab a select. So if I just type in SEL, it will highlight anything that starts with that. Select, click that here, and I can just, with my left mouse button, join these together. Another way you can do it is with your middle mouse, just click here and it will just, you know, if I grab anything, it will just automatically connect it. Okay, so I've got my select. I'm going to press P for parameter, and I just want to select, I'm just going to go back and move my tile. I'm going to use raw 3 for this exercise because it's a nice, clean, simple rotation value. So therefore, I'm just going to resize this window. Okay, I'm going to grab raw 3. You can also, if you want, you can just type 0/raw3. This drop down is kind of convenient, just tells you what's there. It means you don't make spelling mistakes. So that's nice. We've gone from all of these channels to just one channel. The next thing is we're going to want to map this onto values for something else. So in order to do that, we want to sort of understand what range we're working with. So if I move the tile to a vertical position, you'll see that it kind of maxes out around -1000. And if I rotate it the other way, it's about +1000, give or take. So what I tend to start with, depending on you know, how accurate I need to be, I tend to take that as my starting range. So I'm going to middle mouse button here and I'm going to add a math. And what I'm going to do is I will, in the range here, I'm going to map it from -1000 to +1000. And by default, that's in 0 to 1. And you can see now we've got a value of 0 to 1. And let's just leave that there for a second. We'll probably change that to something else in a moment. But now let's set up something for it to rotate. So just for in reference to some of the other projects we do, I've been using a 3D model of a violin bow. And the reason for that is that it also shows you how to use a 3D model in general in TouchDesigner. So in TouchDesigner, we need a few things if we're going to use 3D objects. The first one, this is, it feels a little complex, but basically we need a camera that's going to render the 3D model. We need a light that's going to light the 3D model. And here we're still in the comp area. Oh no, so then we need to go into render, and I need a render top. And once I add that in, it starts automatically connecting itself here. And the last thing I'm going to need is a geometry comp. Once I've done that, our render here, now this is purple. Purple here, if I double click with my left mouse, just refers to tops, which, how to describe this? Tops just means we're sort of in like rendered geometry space. I hope that's accurate enough as simplification. Okay, so now if I take this and now just put that directly as an out or an output, if we go and perform this at the moment, this is what our our scene would look like. It's got a torus that's doing absolutely nothing, being rendered. A camera is looking at the torus, and that's going out as an output. So we're just going to do a few changes to this, such that we'll have the violin bow on a background doing a few things. Okay, so a few things. What we need to do is we need to grab file, SOP. SOP is our three-dimensional objects. That's why I was confusing myself. Okay, so this is purple because it's being rendered in 2 dimensions as frames. SOP, surface operators, these are our 3-dimensional objects. So if we look inside this geo, we will find a torus, which is a 3-dimensional torus. So if I have a look around, here, we'll see that this is a torus, right? And that's what's being rendered by our camera into 2D. So instead of that torus, we're going to use this file in here. And if I press P for parameters and I just click my file viewer here, I'm going to go quickly to this project and go to the assets folder where I've got the bow, and I'm going to grab this bow obj file, and now we've got the bow, and I'm simply just going to connect this to a new geo, which is also going to be picked up by the camera, and then I'll delete that torus. We don't need it anymore. Okay, so now what we've got, if I press this little blue button here, it'll preview what our render is going to look like. Or if I hit render here, you'll see we've got the violin bow. Obviously it's too big. It's taking up too much of the screen. If I hit escape, I can get out of that render mode. One other thing is I should just remind you to file, save as while you're working. If I go to the Stanford workshop and our project files, let's just call this workshop demo tutorial 1. There we go. Okay, so back to our network here. So in our preview, we can see that the violin is far too big. Okay, so there's various things we can do about that. If I right-click here, another way I can add an operator node is left-click Insert Operator after right-clicking on the little wired connection here. So I'm going to add a transform node here. And if I press the parameter window and this uniform scale, I can make the violin smaller, right? So now our violin is sort of within the frame, so that's good. You can see pretty quickly that we've got these rotation values here, which should be in the order X, Y, Z. So one of these values, we're just going to grab our rotation value here and send it here, and then we'll have the rotating bow. If I just pop a number in here, like 45, we'll see that that's not the axis we want. That's sort of rotating it along the length of itself on the X-axis. If I put it on the Y-axis here, that is rotating it also on the axis that's sort of looking vertically towards us. I can also hold my mouse here and see like that. That might be a little easier to see. So by process of elimination, if I hold my mouse here and just go by power of 10, this is to me where we want to rotate, and this on TouchDesigner is the Z axis. So what I can do, taking our OSC input here, I'm just going to add one more thing here by middle mouse clicking and putting a null there. So there's our raw 3, and if I give my SensorTile a roll, we can see it's there. If I go to this transform node here, if I just make that viewer active, that little plus there, I can drag this onto this rotation axis and hit export chop. So if I do that, what we'll see is we're getting a very tiny rotation that's now going from here, and if I open this up, it's basically grabbing null 1 and then the channel raw 3 or 0/raw 3, but we're not getting much rotation. So let's have a look at this math. This math, we're taking our range of the whole sensor from -1000 to 1000, we're going from 0 to 1. And given that this rotation is measured in degrees, of course we're not rotating it very much. So if I convert this to something like let's try first -180 to 180, which will be a full 360. We get our rotation, but it's too much, because when I was testing this, really we're only looking at basically like a 180-degree rotation. So here we've got -180 to 180, which is 360. So if we pop this back down to -90 to 90, then we should have a reasonably good correlation. I'll just hold the tile this way and it should make more sense, between the bow, or the virtual bow, and the tile. However, we can see it's super, super jumpy because these sensors are, you know, quite accurate, but also in a way can be a little bit noisy. So what I usually do is I will filter this a little bit. So if I just spread this along, and this is the reason that I use this null here. You can think of a null as the final placeholder or the final address of that signal you're going to send out. But you want to make sure you've got some extra space to do some more mapping on that signal before you send it out without affecting that final address. So that's why the null is really useful. So what I'm going to do in here is I'm going to right click on this link, hit insert operator, and this time I'm going to add a filter. So by default, you can see now we've got really smooth, but we've got a lag of about, feels like about half a second or something like that. So what we can do is we can just pop these both down, and as we pop them down, you'll see the noise will come back. And to be honest, the simplest way that I do this is I just tend to play around with the numbers, and depending on the utilization of what I'm doing, there's different ways we can filter it to get something reasonably smooth. But here I've made the width of the filter smaller and still left the effect on, and that's pretty good. So we're almost there. I'm just going to add a few more steps. One thing we don't have is a material. So for those of you who have ever worked in 3D, you'd know that by default, a 3D model is typically just gray with no material. And here we're getting some of the lighting from this light here hitting the bow. So we need to add a texture. So what we can do, if I double click and I go into the matte or materials here, I'm going to add what's called a Phong material. We can talk about this more in our live session if you want to know a bit more about what all these words mean and, you know, what's the difference between all of these different types of materials. I'm happy to discuss that. But here we're just going to be pretty simple. Actually, I'll show you one thing first. If I put on a constant material, we'll look at the difference between these two. And I just make it, you know, yellow. If I drag that constant onto the geo, and it'll ask me what parameter I want, and I'm going to say material. Okay, it's made that violin bow a completely flat yellow. So constant means that it's not looking at the lighting information. It's basically emitting that color wherever the camera can see it with full luminosity. Whereas this one here, it will receive lighting. So on the constant, first of all, instead of that color there, we can add our texture map of the violin texture. I'm going to go into my tops here, and I'm going to grab what's called a file in. Oop, I need to type it here. File, movie file in. Movie file in can also be a two-dimensional image. It's just basically it's looking for a 2D image or video. And here, I'll go to the Stanford Workshop, go to our assets folder, go to the bow, and this diffuse map, these are the color textures that we're going to add to the bow. So I've got these here. If I drag this onto the constant, you can see that now we have our textures, but we have absolutely no lighting. So everything is super flat. So if I go to my perform mode, you'll see we've got this like very flat textured violin, and it doesn't look great. But if we drag this onto our Phong as our color map, and then drag our Phong on here instead as a material, and then I perform that, you can see it. It's actually receiving the lighting, and we're sort of getting, you know, the way the light hits, especially the bow frog. It just looks a little bit more, kind of looks like a nice computer game from the late 90s or something like that. We could go more into texturing. There's many different ways we can add textures to make things look weird and wonderful or more realistic. But for now, I think that's more than enough. So I'll delete that constant because we're not going to use it. So now I've got our violin bow textured. The final thing we can do is we can add a background. So if I right click here, there's a number of ways to add a background. I could add a transform here. This is the simplest way to do it. And we simply say, go into background color, and I put the alpha to 1 and say composite over background. And basically that's saying whatever the background color is, composite our render, which at the moment has an alpha channel, and it's compositing it over whatever the background is. That's like the simplest way we can add a background. But we can also add a background in the way that you would in something like Photoshop, if you think about this like layers. So let's do that. So what I did in the previous example, I believe I had a ramp, like a color ramp here. And instead of it being horizontal, I made it radial. No, circular. That's what I did. And I think I played with the period and the phase until I got, you know, something vaguely optically distracting. And then I'll just look in my my resolution. I believe if you're using the free version of TouchDesigner, you're limited to a resolution of 1280 by 720. So I'll just set that there, and I'll just check in our render that we're rendering the same, 1280 by 720. And that's basically saying that whatever 2D image our camera is rendering, now we're in 2D space with this pixel dimension. And if we want to composite these in a way that kind of is logical, it's good to have them at the same resolution. So I'll remove that transform for a second, and we'll composite it in, to me, a way that gives you a bit more control, which is if we insert an operator called composite. So if we pop that there, it'll give us this red X, which means something's missing. You can click on it and it'll say not enough sources specified. But if we drag in our ramp, at the moment, it's done a change, and that's just depending on what our composite setting is. At the moment, it's set to multiply, so it's multiplying the values of one by another, but we can just go atop, and there we go. We've got the, you know, the violin bow is now on top of the ramped background. The ramped background we could change in all sorts of ways. We could, you know, change its color, its value, and we could even animate it. Like we could, you know, we could have a number either from our, our sensor coming in here, or we could even do something like grab a signal, like from chops. We could get an LFO, which is just a low frequency oscillator. It's a number going between 0 and 1. If I slow that down, I have no idea. This might be horrible to look at, but if we go into our ramp and I put the LFO onto our phase, well, our phase at the moment is going between, okay, this might look absolutely terrible, but let's just put a null here, grab that, go into the ramp, drag this onto the phase, export chop. Okay, yeah, it's not actually too bad. It, you know, might be kind of annoying to look at over time, but at least you get the point, you know, we're just grabbing different values and putting them where we want them. The final thing in my example I had was, you know, I had lots of violins. Now there's different ways to do that. I'm going to turn this off because it's going to probably make us all seasick by looking at it. So I'm just going to go into this phase, right click and say remove export so it doesn't drive us crazy looking at it. Okay, so if we wanted to have lots of violins, to me there's at least two ways to do it. We could either duplicate them in the 3D space with what's called an array or instancing, or we could duplicate it in the 2D space, because now that we've rendered it into 2D, we can just copy this series of 2D images, which to me has even less compute than copying the 3D. So a way we can do that, I believe, we'd probably add a transform here, and maybe another one, and that also goes into the composite. And now I just want to make sure that our ramp is at the bottom, so I'm going to bump this one up. And now if I just move this, so this is again X and Y. If I hold this here on Y and I move it down, now why are we not seeing the first one? Let's just, what's happening here? Composite, top. Why are we not seeing that? Okay, that's interesting. What have I done wrong here? So I've got bow 1, bow 2. We should be seeing them both. Okay, so sorry, I was atop where I should have been over. I'm directly overlaying them. Okay, so sorry, that was quite something simple. Okay, so now if I chuck my ramp on the bottom now we've got two bows, and as we had before, in the scale, I can make these a little smaller, make them like 0.8 each, and make this one 0.8, this one 0.8. Okay, so now we've got two violin bows, basically taking the same signal in, we're just duplicating them before compositing them back into a final signal. Okay, so that's it for our first tutorial. Maybe just to sort of round it off, I'll just show you that, of course, we don't have to use a violin bow. And the nice thing about TouchDesigner is that we can keep, changing this later on. So, for example, if I grab like a box, and, I'll put in a transform here, just so we can make it a little bit smaller. We can even make it larger on the Y. And here we can even, let's be nice here. Let's put a switch in here, and I'll put, just so we're non-destructive, I'll put the box in here. So if we take this switch now and add one to its input, we've got the boxes. And already this is kind of nice because we're still using the texture of the first geo, but we've got this sort of weird thing going on where the box is doing that. The box, I could also like rotate it a little bit before, now we can kind of see that it's a 3D box. We could really sort of have a play with it. And they're, basically the principle of having different 3D shapes. And if I take my switch and put it back to 0, you can see you can do a lot with this. But the main idea of this tutorial is just showing you how to start with grabbing a signal from our OSC, transforming it with math and filter, and then attaching it to the various parameters that we need in order to use it to make this very simple. I realize I've recreated the Looney Tunes credit scene. Okay, I'll end this one here. Okay, bye-bye.